Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our 6.2.1 homework. The M&Ms for this is how to use an equation mat. And, really, the equation mat is the same thing as those expression mats that I was showing you in the early part of this chapter, except we now know the relationship between mat A and mat D. We're saying that they are equal to each other. So what we need to do is use all the legal moves to determine what value for X makes them equal to each other. And this could be an absolute nightmare, going through the process of just making up numbers and running through on this side and on this side to see how long it takes before they're equal to each other. You could do that, but once we start getting into decimal and fraction values for X, you will not want to do that. So we want to learn this process. So this says 2x minus 3. No, it doesn't. It's 2 times x minus 3 is 2x minus 6 plus another x plus 4 is going to be equal to 9 minus 2 x's, or plus 2 negative x's, plus the 1 plus the x. So your first step would be really to rewrite this. Honestly, I would combine like terms. That's how I would describe it. Let me use this color here. So that's going to become, what do we end up with here? 3x's. And then what do you got? Negative 6 and positive 4 gives you negative 2 on the left side. And on the right side, you're going to get a 0 pair here. So that's going to leave you with a negative x and then a total of 10. A nice negative x there. Let me clean that up a little bit. No, negative x. What are you thinking? You got 10 on the brain. Okay, there we go. And so then what do we do? Is that what this says here? 3x minus 2 is equal to negative x plus 10? Yes, it is. And so then add balanced sets to each side. So I would add 1x to each side so that this guy cancels out, but now you got 4 of them on the left. And I would also add 2 1s to the left side to cancel out these two guys. But then you add 2 1s to this side as well, and that becomes 12. So the x is canceled out from the right, leaving you only with 12 1s. The 1s cancel out on the left, leaving you with 4 x's. So 4 x's are equal to 12. So then you break those into 4 equal parts. How much would each x have to be equal to? Well, each x is 3, right? There's an x equals 3, x equals 3, x equals 3, x equals 3. 4 x's equals 12. So when you divide the number of x's by that number itself, by the coefficient, you end up with the 1x is equal to 12 divided by 4 is equal to 3. If you wanted to check that, you could put in a 3 here, a 3 here, a 3 here, a negative 3 here, a negative 3 here, and a 3 there, and then add everything on the left, add everything on the right, and they would balance out perfectly. Right. So write the equation, the original equation represented here. This is 3x's, right? Plus 3 equals 12. Simplify the tiles on the mat as much as possible. Okay, so if we remove balanced sets, that ends up being 3x's is equal to 9. And then when we divide these guys evenly, each one of these x's has to be equal to a 3. So x equals 3, and that absolutely works. Now here's the check. There's a 3, there's a 3, there's a 3. That's 9, 10, 11, 12 on the left, and of course we've got 12 on the right. They are equal to each other, so we know we've got the correct solution for x. When Lakeisha solved the problem 3 times x plus 1 equals 12 from problem 54, she reasoned this way. She said, since 3 groups of x plus 1 equals 3 groups of 4, then I know that each group of x plus 1 must equal 4. Do you agree with this? And she is right. 3 times something has to equal 12, right? So the only number that can go in there is, stop. The only number that can go in there is the number 4, which means this quantity, x plus 1, has to equal 4. So what do you add to 4, or add to 1 to give you 4? This is going to have to be a 3, and eventually that ends up being your solution. X is equal to 3. Now, my preference when solving these problems would be to use distributive property. I just like doing that better. Although when these become absolute value types of problems, we'll want to divide by 3. But we'll let your high school teacher show you that. Here, we'll just call this 3x plus 3 is equal to 12. Take 3 away from each side, so it's 3x is equal to 9, and you still end up 3 times 3 is 9, so x has to be equal to 3. That is your solution. All right. In problems 54 and 55, 3 times x plus 1 could be written after using distributive property, right, as 3x plus 3. So by using distributive property. The expression here is a product, while this is a sum. Okay, good to know. For each expression below, write an equivalent expression that is a product instead of a sum. So they are asking you to do the process of factoring, which is the reverse order of distributive property. So remember, here, 3x plus 3, if you think about it like we do with fractions, and then one of them's a numerator and one's a denominator, what's the common factor? It would be 3, right? So you pull the 3 out, and then you think, what would you multiply times 3 to give you 3 x's? An x. What would you multiply times a 3 to give you 3? A 1. So this would be the factored form of that. So here, look at the 25 and the 50. What do they have in common? They have 5 in common, but they also have 25 in common. So let's pull out the 25. What would you multiply times 25 to give you 75? It would be 3, and then it's 75x, so we're going to call it 3x. And what would you multiply times 25 to give you a negative 50? That would be the negative 2. So when you want to know for sure if you've got it right, send in the dive bombers and show that 25 times 3x gives you 75x, and 25 times 2 gives you 50. And remember, that negative sign or that minus sign is between them. So this is correct. So in all of these cases, find the greatest common factor of your coefficients. In this case, it's kind of tricky because they also had an x in common. So you'd factor that out as well. So 32 and 48 have 16 in common, but x squared and x also have x in common. So 16 times 2 is 32, and x times x gives you the x squared. This only has x to the first power, so you just take 16 times 3 is 48, and the x goes along for the ride and becomes 48x. When you get into chapter 8, at the beginning of chapter 8 in 8th grade, we're going to talk in more depth about exponent rules when you're multiplying variables with exponents. Okay. I'm going to go ahead and you just check and see if you understand how to get these. If you want me to work those out, let me know, and I will help you with those. All right, evaluate the expression. Once again, you take the value for x and you plug it in here, and then use the order of operations. 5 plus negative 3 times 3 becomes 5 plus negative 9, which is negative 4. 1/3 of negative 3 would be negative 1, so 5 plus negative 1 is 4. And negative 3 times negative 3, this is interesting, 5 plus negative 3 times negative 3 is going to be positive 9, right? Because the negative times a negative, and 9 plus 5 is 14. All right, which fractions below are equivalent? This is a really good question because I often get questions from students asking, does it matter where you put the negative sign? And I say, no, it technically doesn't. Just remember, most of the time when we write a negative fraction, we put it on the outside of the fraction, but I will often write it up in the numerator. It's sometimes easier to have it in the numerator. But technically, you could have it in the denominator if you wanted to, because all fractions are division problems. So the answer to each one of these problems, B, C, and E, is 20 divided by 5 is 4, and it's a negative divided by positive, so you get a negative 4 for an answer. Positive divided by negative is going to give you a negative answer, and the opposite of 20 divided by 5 is the opposite of 4, which is negative 4. In this case, 20 divided by 5, they're both positives, you get 4 for an answer. But a negative divided by a negative also gives you a positive answer. So these two, A and D, are equivalent to each other, and then B, C, and E are equivalent to each other. All right, and then these problems, these are horrible. You guys, have we talked about fraction busters yet and decimal busters? I don't think so. This must be getting you ready for that kind of a process, which even the 8th graders don't like solving these problems. If you got a calculator, it shouldn't be too much trouble to solve these problems, right? Just take 8.4 times 7, which is 58.8x, and then 8.4 times 4 is 29.7. No, it's not. No, it is not. Let's check this. I feel very good that 8.4 times 7 is going to be 58.8x, but 8.4 times 4 is what? 8.4 times 4 is 33.6, so it's going to be negative 33.6 plus 3.9. So this is a negative plus a positive, so I'm going to subtract these numbers and keep the other sign. So let's do a subtraction. Minus 3.9, and it gives you 29.7, but you had more negatives here than positives, so it's going to be the negative 29.7. Here, you probably want to get common denominators. So, I'm so sorry. This is not a fun problem to solve. Why do they do this to us? Is this the last one? Yes. All right. How much time have we used up so far? Not too bad. I will do the problem, which is going to require using distributive property, right? So I'm going to rewrite this as 1/4 plus, this ends up being 12 over 20, which I'm going to simplify in a second, times x. And this has to be 9/10. This is going to be negative 10 over 9 times 4 over 5. So this is going to give me minus 40 over 45. Okay, so here's the good news. Once I simplify this fraction, I don't have to add this to anything because that's the only x term here. So 12 divided by 20, well, we have 4 in common, so it's going to be 3 over 5x. And then we have to add 1/4 and negative, so I'm going to do a subtraction there. So 1/4 minus 40 over 45. Maybe should I simplify that? I think I will. That ends up being 8 over 9. Right? Divide both by 5, 8 over 9? Yes. And now I'm going to do my coat of arms. It's going to become 9 over 36 minus 32 over 36. So 9 minus 32, let's see what that is. 9 minus 32 is negative 23. So that becomes minus, yeah, over 36. 23 over 36. And there we go. Yep, that's the answer. Hooray, we got it right. All right, so we are done with this homework. Let's move on to the next activity. Take care. Bye.
Hey, feeling good, like I should.